My name is Daniel Liden. I'm a developer advocate at Databricks, and today I am going to talk through how to use MLflow tracing to get complete observability into your GenAI applications and API calls and agent frameworks with just one line of code. So let's get right into it. So we'll start by looking at a more or less realistic scenario. I've certainly run into cases like this before. You're working with some kind of agent framework. You know, there are multiple different API calls, tool calls, possibly handoffs between agents, and something goes wrong. And by default, the framework might give you a response that looks something like this. I'm unable to retrieve the details for product ID P120 at the moment. Okay, why not? This doesn't really point you in the right direction. So this is one of the areas where MLflow tracing can be extremely helpful. So let's look at what this looks like with tracing. Now, with MLflow tracing enabled, we can see the whole workflow and all of the different steps. We see that there are multiple agents, handoffs, tool calls, and we can pinpoint what step things went wrong in. We can see that this error is highlighted in red here, and we can look at the Events tab and figure out exactly what that means. And we can tell the exception took place in the lookup product details tool. And a lot of times that's all that we need for a next step to figure out how to fix our agent. We're going to go into the specifics of this example a little bit later, but for now I want to get into the hands-on section and take about 5 minutes to show how MLflow tracing actually works in practice. So as always, we need to start with a little bit of setup. In this case, I'm working in a virtual environment, and I would recommend doing that for you as well. So we start by installing the dependencies. Of course, we'll use MLflow. I'm going to show examples using both OpenAI and Anthropic, so we'll want those. I use the python.env library to read API keys from a env file. And then we're going to use the new OpenAI Agents SDK, and so we'll want to install that library as well. This example also assumes that you have obtained and set up an OpenAI API key. You can, again, either read it from a .env file or export OpenAI API key equals your OpenAI API key in the terminal. So first, let's look at what we get if we're not using tracing, just to have a good basis for comparison. So we import the libraries that we need, and we're just going to run a really simple chat completion with GPT-4o Mini. We'll ask, what is an MLflow tracking server? And this is what you get back. This is not the most useful format to read things, though I'm not going to focus too much on that because, of course, you could do whatever you want with the text, print it out however you'd like. But by default, it's not the easiest thing to read. And now suppose I read it and I think, that response was a little bit too strange, a little too far afield from what I asked, and I want to change the temperature. So change the temperature to 0.5, make the response seem a little bit less random, and we'll run it again. And now we'll get another result back in just a second here. And, maybe you read that result and you think, okay, it's definitely different from the first one, but I don't remember exactly what the first one was. And if I run it again with that temperature, it's going to give me a different answer anyway. So you've kind of lost track of the results of your experimentation. That is one of the major places where MLflow tracing comes in. So to enable tracing, we're going to call this one line of code, mlflow.openai.autolog. And this is an important point with tracing MLflow tracing supports a lot of different providers, and they pretty much all follow the same pattern. MLflow.pattern.provider.autolog. And that's all you need to do to enable tracing. Optionally, but we do recommend this, you can set an experiment name. This will just namespace all of your traces under one experiment, making them easier to find, easier to separate out your different experiments. So now let's run this with tracing. And while we're waiting for that to run, to actually view the traces, you need to call this we'll do that. And I'm calling it on port 5001. By default, it uses port 5000. You don't need to worry about that. And it will tell you the link to follow to see the UI. I'm going to click on that. And let me switch to that screen. So from here, we can take a look at the MLflow UI. Remember, I created the OpenAI experiment to follow this, and we can find our trace. So and I'm going to click into the experiment that we created, the OpenAI example. I'm going to click over to the Traces tab, and then the trace that we created is right here. And now we can see all of the inputs and outputs, the system message. This is all very nicely formatted, markdown, much more readable than the default outputs. We can go into a little bit more details in the Inputs Outputs tab, see the raw responses, the model name. Basically, everything that is returned by the OpenAI API gets tracked here. Now, another nice feature is that once we have started the MLflow UI, we can actually preview the traces right in the notebook. So you use this call, MLflow.setTrackingURI, to point to the tracking server. And once that is set, when we make these calls again, the previews will show up right in the notebook. So for the sake of demoing this, and just for a little bit of variety, I put together a different example. We're going to use OpenAI's structured outputs, where we pass a pydantic model, this, as a response format in the API call to make sure that the response follows the format that we're looking for. So in this example, I'm passing in the details of an event. In this case, it's actually an MLflow meetup that we held earlier in the month. And I'm asking the model to extract the speaker names, the date, the number of attendees, and the description. And this is just a raw description along with those details copied straight from YouTube. So now, when I run this, we will see the results directly in the notebook. And we don't need to leave the notebook anymore to keep an eye on all of this. Once again, all of the tabs are there. You get the full featured tracing experience right in the notebook. And we can go look at the structured outputs that we got. We got the speaker name, we got the date, attendees, description, right in the notebook. So that gives you enough to get started with as far as capturing traces. It's one line of code. We support a lot of different providers, and I'll talk a little bit more about that later. But fundamentally, all you need to do is install MLflow, and then depending on the library that you're using, call MLflow.provider.autolog, be it MLflow.langchain.autolog, Anthropic.autolog, CrewAI. We support a lot of different providers with that one line of code automatic tracing approach. One more note on the notebook display, you can disable it if you don't want it showing up in the notebook with this MLflow.tracing.disable notebook display call. Now, what do you actually want to use traces for? Most of what I've shown so far is that it gives a nicer interface to view the result. But like I said, you can do whatever you want with the text output from an API call. You don't really need to bring in a whole tracing system from that. But tracing does offer a ton of different benefits if you're working with any of these GenAI or agent APIs. First of all, as we showed at the beginning, it's extremely useful for debugging, particularly if you are working with an agent that has multiple different components, tool calls, different agents, things like that. It can be really difficult to pinpoint the step where things actually went wrong if you run into an error. This makes it pretty easy because anything that happens is captured in this events tab, including errors, and you'll be able to pinpoint the exact step where something went wrong and how to fix it. Tracing is great for informal experimentation. Above, I was talking about how if you try to vary the temperature, for example, on different OpenAI calls, it's very easy to lose track of your experimentation, particularly if you run a few informal experiments and you kind of figure one temperature is better than another, and then you walk away for lunch and you come back and you look at your notebook. It can be really difficult to figure out what you were keeping track of, what stage you were at in your experimentation. If you enable tracing, every one of your API calls is logged and you can go back in and find it. So you don't lose anything as you're doing this kind of informal experimentation with different prompts, different parameters, things like that. OpenAI tracing, or MLflow tracing rather, also generates a lot of data that you can use for various downstream tasks. You are able to export all of your traces. You can extract the texts. You can use them for evaluations. You can use them for fine tuning. Whatever purposes you want to, you have a whole record of all of these different interactions with your models. It's also fantastic for sharing if multiple people are collaborating on an experiment and you're using the same MLflow workspace, you can look at your colleagues' traces. From there, let's go on and briefly talk about organizing traces. Now, we've talked a little bit about this already. We created an experiment to capture our example traces at the beginning, but there are a few other ways that we can do this. So in this case, I'll show how to organize traces with runs. An MLflow run can be used to capture multiple traces if you want to group traces logically for some reason. So in this case, say we expand our example about extracting event descriptions, and we're trying to capture multiple. And we're capturing those with all of the same model parameters, all of the same system arguments, the same pydantic model and everything. We just want to make sure that they're actually grouped together and we can see that they were part of the same execution. So we can run this. And in the UI, in the notebook, we'll get this tabbed view where we can look at both of the different results. And then if we go back to the UI, we can see that in the runs tab, as opposed to the traces tab, we have a new run that was created. The run itself has a traces tab, and we're able to isolate those specific traces that we ran in one much more specific context that we want to be able to look into. Now we can also go back to the traces tab and see that those traces are still available in this tab, but they specify a run name. So this is one additional very useful way for organizing traces into a smaller, more granular approach than the experiment. Now, we can also organize traces with tags. This can be extremely useful. So maybe we want to indicate with a tag that this was an experiment that we did using the structured outputs. So we can create a new structured key with value true and add this. We'll save the tag, and now we can see that it's here. And this gives us a way to search. So say tags dot structured equals true, do a search, and we see that only the results that have this structured equals true tag are returned. So tags provide another very powerful way to handle organization of your traces. You can set whatever kinds of tags that you want to just give a number of different ways to search and filter your traces. So like I've mentioned, MLflow tracing supports one-line automatic tracing for a number of different providers, not just OpenAI, and we're adding more all the time. So LangChain and LangGraph, Llama Index, so plenty of agent frameworks, DSPy, Anthropic, which we'll show below, Mistral, Ollama if you're tracing local calls. For the most part, you use these in exactly the same ways we did OpenAI. So you'll do mlflow.providername.autolog. In some of these cases, for libraries that have an OpenAI compatible SDK, we'll provide tracing via the OpenAI autologging, and you'll set the OpenAI base URL. So I think Ollama is an example of that, where you can get tracing because they have an OpenAI compatible SDK. So let's quickly look at Anthropic just to illustrate how this works. So in this case, I have my Anthropic key in this Liden file. We're actually going to start by showing what happens if we don't load the environment variables. But for using tracing, we'll just call mlflow.anthropic.autolog. Same exact pattern as with open. Then we'll call this. I guess I had already had an Anthropic key in the environment, so my attempt to show an error didn't work out. But as you can see, just like with OpenAI, the Anthropic autologging captures your inputs and outputs, and all of the different parameters, temperature, number of tokens. You get usage information, all of the same things as you got from OpenAI, and it's exactly the same approach. One line of code, mlflow.anthropic.autolog, and you automatically get all of that additional visibility. So continuing on the thread of looking at multiple different providers, let's look at the relatively new OpenAI Agents SDK and see how tracing works with a more complex agentic kind of workflow. So in this case, we will set up a kind of customer support agent workflow. This will have a few different agents. We'll have a product specialist agent that helps customers with product information, a technical support agent that helps with API connection issues and technical problems, things like that, and a triage agent that decides, after getting the initial query from the customer, where they need to route the request to, be it the product agent or the technical agent. We'll also set up a tool, this lookup product details tool, and this one's very simple. It assumes that there are only 3 tools with these different IDs and different plans with different pricing and numbers of API calls. So the idea is that a customer will ask a question. The triage agent will see the question first and decide, is this a technical support question or is this a product information question about one of the product lines? Based on what the triage agent decides, it will route the request to one of these 2 agents. The product agent in particular might then invoke the lookup product details tool, and then finally respond to the user. So we're going to run this with the query, what features are included in the plan? I think the product ID is P120. You might remember this from the example I showed right at the very beginning. We'll wait for this to run just a minute, and then we will look at the trace. So we got this response, and this again might look familiar. I apologize for the inconvenience. It seems there's an issue retrieving the product details at the moment. Again, that doesn't really tell us where things went wrong. But the trace does. We can tell that it was the lookup product details. An error occurred while running the tool. The error is particularly around this product ID key. The product ID input was P120. So now we can look back at the function and try to understand why this went wrong. So look up product details. Let's look at what this does. The available products are P100, P200, and P300. No P120. And when we try to return product's product ID like this, that's going to return an error if the product ID that is passed in isn't correct. So let's change this to use products.get product ID with a default value if the product ID itself is not found. So in this case, if the product ID is not found, inform the customer that the available products are P100, P200, and P300. So this gives a fallback in the case that there's an incorrect product ID. And then we can run this again. And now, in this case, seems that the product ID P120 is not available. However, I can provide information on products with the IDs P100, P200, or P300, which is much more helpful. It tells the user what the valid results are, and it also means that we're no longer seeing an error with that function. We have it configured to actually run correctly. And let's take just another minute to actually look at the rest of this trace now that it's working correctly. We can follow the whole execution path. We see that first it goes to the support triage. We can see the tools available to the support triage agent. It can transfer to the product specialist or the technical specialist. We can see the system prompt, the user request, and then what the assistant ultimately decides, which is to call this transfer to product specialist handoff. We can look at the handoff itself. And this handoff is from the support triage agent to the product specialist agent. And then we can see that reflected in the trace. So we see the same sort of things for the product specialist, the system request or the system message saying that you help customers with product information, the user request, and then the assistant knows that it needs to call the lookup product details function with the product ID specified by the user, P120. We can look into the actual tool call, the input, P120, and the output. Now that we've set it up correctly, is product not found, inform the customer that the available products are P100, P200, P300. And then we get the final response to the customer, which we saw above. It seems that the product ID is not available. So this was a quick example of how we can use MLflow tracing to debug an issue that arises when working with an agent framework that has multiple steps that are often somewhat opaque in the moment. We were able to pinpoint where the issue was in the specific function, look back at that function and figure out what was wrong and fix it, and then consult the trace again and see the completed working agent workflow. And that is all we are going to cover today about MLflow tracing. To recap some of the points, MLflow tracing is a very powerful GenAI observability tool that gives you a ton of additional visibility into the execution flows of your GenAI applications, API calls, and agent workflows with just one line of code, mlflow.provider.autolog. MLflow tracing is extremely useful in a variety of contexts, whether that is collecting the results of informal experiments so that you can consult them later and get an understanding of what different parameters worked well and what didn't, and what prompts worked well and what didn't. Whether it's for debugging, making it easier to identify the steps that went wrong, and it's also extremely useful for generating data sets for downstream tasks, such as evaluation or fine-tuning. There are many more things that you can do with tracing. You are able to trace anything, not just GenAI applications, using the MLflow Fluent and Client APIs. So you can trace individual functions, you can trace different execution flows. There are a whole lot of customization options beyond what we showed here with auto logging. You can export and search your traces programmatically, which is very helpful when you're generating data sets. Yeah, and I think that is a good place to leave it. I will make sure that this notebook is uploaded so that you can use it, see the description, and also link to a bunch of additional resources of more things you can do with tracing. Thank you very much.